So today's presentation will be talking about the introduction of differentiation, what and why apply maximum and minimum problems, problem statement, what to solve, problem solution, and how to solve it, and also the conclusion.
What is differentiation? To begin with, what is differentiation? Differentiation is the process of finding the derivative or rate of change of some function, which describes how the functions change as its independent variable change. The derivative represents as dy over dx of f prime x to measure the rate of change of the function with respect to its independent variable. When do we apply differentiation?
So, when do we apply differentiation? Differentiation is used to find the rate of change of a function or derivative, and is applied in many fields, including physics, such as calculating the rate of change of motion, engineering, economics, such as finding the demand and supply, and also the marginal cost. And in biology, we use to find the rate of cell growth. So, application of differentiation, we find the trend. We use differentiation to find if quantity is increasing, decreasing, or constant. The second one, find the slope. We use differentiation to find the slope of a curve or a tangent line to the function. The third one, solve optimization problems. We use differentiation to solve problems that involve finding the best solution. The fourth one, analyze function behavior. We use differentiation to analyze how function behaves. Application of differentiation, we have 5 parts. The first one, related rates, analysis of function 2, apply maximum and minimum problems, and the last one, Rolle's theorem and mean value.
What is applied maximum and minimum problems?
The process of finding minimum and maximum problems are problems that involve finding the maximum or minimum value of a quantity, also known as optimization problems. For example, 1. Finding the maximum profit for a company. 2. Finding the minimum cost of producing an item.
Why we use applied maximum and minimum problems?
First, we have used derivative to help find the maximum and minimums of some function given by equations. Second, many of problems can be solved by finding the appropriate function and then using techniques of calculus to find the maximum of the minimum value required. Third, to find the best way to do something such as maximize profit or minimize cost.
Problem statement. A closed rectangular box with square base to hold 316 cm cube. The material for the side and the top or base cost Rm1 ringgit and 50 cent per square cm and Rm2 ringgit and 50 cent per square cm respectively. Let X donate the side of the base and Y the height of the box as shown next. So now we have to prove that the cost of material is equal to 5x squared plus 2160 over x. So we have to find the surface area of the box. As we have one top and one base, we have to multiply it with x squared and the cost for the base and top, which is 2 ringgit and 50 cent. And we add with, as we have 4 sides, we have to multiply it with x and y and the cost for the side, which is 1 ringgit and 50 cent. Next, as the rectangular box volume has been given in the question, so we can assume that x squared multiplied with y is equal to 360 cm cube. And then we make y as a subject. Now, we have to substitute the y into the formula that we have been calculated at the cost of c. So, now, the equation will be 5x squared plus 6x, and we substitute the y, so 316 over x squared. Then we got the 5x squared plus 2160 over x, and the equation now is proven.
For solving these problems, there is 3 steps, which is, first, we need to find the derivative of the equations. Which is, the equation is c equals to 5x squared plus 2160x to the power of negative 1. So, the derivative is dc over dx, which is we get 10x minus 2160x to the power of negative 2, and the answer is 10x minus 2160 over x squared. Next, the second step is we need to let the derivative equals to 0. This is because we need to find the value of x. So, in this problem, we got the value of x is 6 cm. Lastly, the third step, we need to do a second derivative test. This is because we need to know the value of the x is a minimum or maximum. So, in this problem, we got 20 for the second derivative test, which is more than 0. And this is proof that the value of x equal to 6 cm is a minimum value. For the value of y, we need to substitute the value of x, which is 6 cm, into the equation, which is 360 over x squared, and we got the value of y equals to 10 cm.
Problem C. In problem C, we need to find the minimum cost of the box. To find the minimum cost, we need to substitute the value of x with the answer in problem B, which is x equal to 6 in the cost given 5x squared plus 2160 over x. So, 5 times 6 squared plus 2160 over 6. And the final answer for minimum cost is Rm 540. In conclusion, by applying maximum and minimum problems method, we can find the derivative, find the value and the variables. Next, determine the maximum and minimum value. Lastly, we can also determine the minimum cost of the box, a closed rectangular box with square base with 360 cm³ of water. From the given that the side is RM1.50 per square cm and the top base is RM2.50 per square cm, so we got the minimum cost of the box is Rm 540 ringgit.